Hey everyone, welcome back. Today we're diving into large language models, specifically one from MiniMax called MiniMax-01.
Oh, yeah, I've seen this paper floating around.
They're making some pretty big claims in it, saying that it's right up there with the big names like GPT-4 and Claude,
Really?
but they're also saying it can handle a lot more information.
Interesting. So, what's the big problem with a lot of the models that are out there right now?
Well, you know how sometimes you try to give a model a really long piece of text to work with and it just kind of chokes?
Yeah,
Like,
yeah.
it can't really grasp the whole thing.
Uh,
That's the context length issue. Most
yeah.
models just have a really limited window of how much they can actually take in and understand at once.
And that's what MiniMax is saying they've fixed.
Yeah, they claim MiniMax-01 can handle a context window like 10 times bigger than what we're used to.
Wow. So, are they just saying that, or did they actually, show
Oh,
it?
they did a ton of testing,
Yeah.
and they explained how they did it too. It's all in the
Yeah.
paper. That's one of the cool things about this paper.
Huh.
They're not just throwing out buzzwords, they're getting into the nitty-gritty.
So, how'd they do it? What's the secret sauce?
Well, one of the big things is what they call lightning attention.
Okay, I'm vaguely familiar with attention, but what makes it lightning?
Think of it like when you read a book.
Yeah.
Your eyes are drawn to certain words or sentences, right? The important parts. That's kind of like attention in a language model. It's how the model figures out what to focus on. And what MiniMax has done is make that process way more efficient, especially for longer pieces of text.
I see. I see. So it can zero in on what matters without getting bogged down.
Exactly. And that efficiency is key because it lets them handle these huge context windows without the processing time going through the roof.
Huh.
But there's another piece to the puzzle, too. Something called mixture of experts.
Mixture of experts. What's that?
Think of it like having a team of specialists, each with their own area of expertise. Instead of one giant network trying to do everything, you've got all these smaller, specialized experts within the model, and only the ones that are relevant to the task at hand actually get activated.
So it's like if you need brain surgery, you don't go to your dentist.
Exactly. You go to the expert who knows about brains. And that's what MiniMax-01 is doing. It's calling on the right experts for the job.
That's pretty clever.
And it's what allows them to build such a massive model. This thing has 456 billion parameters,
Oh.
but only a small fraction of those are active at any given time. That's the beauty of the MOE approach. You get the scale without sacrificing efficiency.
Sounds great so far. But does it actually work? How does it stack up against the competition?
That's what they wanted to find out too. So they did a whole bunch of benchmarking, comparing MiniMax TextDo 1, which is the text-based version, to models like GPT-4, Claude, even Google's Gemini.
How'd it do?
Pretty darn well. On a lot of the standard tests, it was either right up there with them or even beating them.
No kidding. So they're not just hyping it up. They've got the receipts.
Exactly. They even have a nice chart in the paper, Figure 1, that shows all the benchmark results. And if you look at Table 8, you can see how well it did on things like C-Simple QA, which is a test of basic understanding,
Yeah.
and even math, which obviously focuses on math skills.
Mm-hmm.
But the real test for this model, the thing we're really curious about, is how it does with those super long context tasks, right?
Absolutely. Can it actually make use of that massive context window?
Well, that's what they really wanted to see. So they came up with these tasks that require processing a lot of text, kind of like finding a needle in a haystack. They even have a new benchmark they call multi-round needles in a haystack, or MRNIAH.
MRNIAH.
Catchy. Yeah. And the results are pretty impressive.
Yeah.
MiniMax Text-01 was able to handle these tasks with context lengths up to 4 million tokens.
4 million. That's insane. Most models tap out at 32,000, right?
Yeah, we're talking orders of magnitude bigger here.
There's a figure in the paper, figure 2, that shows how the speed of different models compares as you increase the context size.
Oh, yeah. And it's really striking. You can see MiniMax Text-01 just cruising along while the others start to slow down big time. But here's the thing. It's one thing to design a model that can theoretically handle all this information, but actually making it work in practice is a whole other challenge.
Yeah, you need the computing power to back it up.
Exactly. And remember, this model is massive. So MiniMax had to come up with some incredibly clever optimization strategies to make it all possible.
So, how did they pull it off?
Well, that's what we're going to dive into next. So we know MiniMax-01 can handle a ton of information at once, but how does that actually help us?
I mean, that's really the key question, right? This isn't just about some abstract technical achievement. This is about changing how we interact with information.
Think about all those long, complicated documents we have to deal with. Legal contracts, research papers, those emails that just never seem to end.
Oh yeah, those are the worst.
Even the best language models right now have trouble really understanding those.
It's like trying to figure out a movie just from watching a couple of random scenes.
Exactly. You miss all the connections, the nuances. But with a model that can handle a context window of millions of tokens,
Millions.
yeah, millions, suddenly we can understand these documents in a whole new way. It's like having an AI that can actually read and comprehend an entire book, just like a person.
Wow. And then it could like summarize it for you.
Exactly. Or answer your questions about specific parts, or even compare it to other documents it's read.
That would be incredibly useful.
Think about the impact this could have on education.
Oh yeah, imagine students having their entire textbooks loaded into the model.
They could have these really personalized learning experiences.
Yeah, instead of just passively reading, they could actually have a conversation with the material. Ask questions, get instant feedback,
It's like having a personal tutor who knows everything about the subject.
and is available 24/7.
Exactly. And think about the possibilities for creative writing. Authors could collaborate with the model in a whole new way.
Bounce ideas off of it, get feedback on entire chapters.
With that huge context window, the model could keep track of all the characters, the plot lines, even the themes of a whole book.
It could really help writers create these super immersive stories.
And let's not forget about coding.
Yeah. A model that could understand an entire code base.
No matter how complex it is, help developers write better code, find bugs.
It would be like having this super intelligent coding partner.
All of this is super exciting, but we should also acknowledge the potential downsides too, right?
Of course, like any powerful technology, there's always the risk of misuse.
It's up to us to make sure these models are used responsibly and ethically.
Absolutely.
But for now, I think it's safe to say that MiniMax-01 is a really big deal. And it's going to be fascinating to see how this technology develops.
I completely agree. It's a glimpse into the future of AI.
And in the next part of our deep dive, we'll take a closer look at exactly how MiniMax made this breakthrough happen. We'll get into those amazing optimization strategies they developed.
All right, let's get into the nitty-gritty.
Okay, so how did they actually make this thing work? We've talked about all the cool stuff MiniMax-01 can do, but building a model this powerful and then actually training it and making it run efficiently, that's got to be a huge challenge.
Oh, absolutely. It's like you can have the plans for a super fast race car, but you need a really powerful engine to make it go from 0 to 60 in like 2 seconds.
Right. And in the AI world, that engine is optimization.
Yeah, you got to make sure all the parts are working together smoothly.
And MiniMax had to get really creative here, especially with that whole mixture of experts thing. Remember how we were talking about that?
Yeah, all those different experts inside the model.
Right. And only some of them are active at any given time.
So how do you even train something like that?
That's the tricky part. You're essentially trying to train this whole team of experts, but only some of them are getting practice on any given task. So MiniMax had to come up with these special techniques called expert parallel and expert tensor parallel.
What do those do?
It's like splitting up the workload among your team, dividing and conquering. There are ways to spread out the experts and all the calculations they need to do across multiple GPUs.
Oh, so instead of one GPU trying to do everything?
You've got a whole bunch of them working together.
Oh, lever.
And that's how they managed to train a model with 456 billion parameters.
Wow. That's a lot of parameters.
It is. But they didn't stop there. They also had to optimize for those crazy long context windows. Remember, this thing can handle up to 4 million tokens.
Yeah, like processing a whole library's worth of information.
So they came up with this technique called data packing. It's like
Right.
packing a suitcase really efficiently.
Mhm.
You fit all those different sized things in there so there's no wasted space.
So you're saying they found a way to pack the data more tightly?
Exactly. And that makes the training process way more efficient. And then there's this thing called linear attention sequence parallelism, or LESP plus lat.
LESP plus lit.
Yeah, I have a mouthful. But basically, it's a way to make the processing of those long sequences much faster by breaking them down into smaller chunks and working on them all at the same time.
I think I get it.
They actually have a diagram in the paper, figure 12, that shows how it works. It's pretty cool. But the optimization doesn't stop there. They also had to make sure the model could run efficiently when it's actually being used, not just during training.
Right, because no one wants to wait forever for the model to answer a question.
Exactly. So they came up with a bunch of techniques to optimize that lightning attention during inference. It's like, having a powerful desktop computer versus a sleek laptop. You need the right tool for the job. And MiniMax figured out how to make their model run smoothly on both massive computing clusters and individual GPUs.
Impressive.
Really impressive. They squeezed every ounce of performance out of the hardware. I think they said they achieved over 75% model flops utilization on the NVIDIA H20 GPU.
Yeah, that's really good.
And the best part is they're sharing a lot of what they learned with the open source community, so other developers can benefit from their innovations.
It's a win-win for everyone.
We've gotten pretty deep into the technical stuff here, but I think it's important to step back and just appreciate what they've accomplished. This isn't just a faster, more efficient language model.
It's just like a whole new level of AI.
It's a glimpse into the future, where these models can really understand and work with information in ways we never thought possible before. It's a really exciting time to be following all this, and I can't wait to see what they come up with next. Thanks for joining us for this deep dive into MiniMax-01.
My pleasure.